Okay, so for exponents, we're going to go through adding polynomials, subtracting polynomials, multiplying, and then dividing. So first for adding, so when we were going through and graphing lines, we saw like 4x plus 5. And that's as far as we could go because this guy has an x and that one doesn't. I always say guy. My students would always make fun of like, what does this guy need? They're like, it's not a person. But so they can't combine because that has an x and that one does not. So I'm going to go through though, and we're going to go through ones that can combine. So I'm going to add on to this. So if we had plus 3x and minus 10. Okay, well now this has an x and this has an x, so now they can combine. So those are called like terms because they both have the same variable on them. So if they have the same variable, then they can combine. So let's add in another letter in here. Let's make it plus, let's use m. So 2m minus 8m. Okay, so now everything that has an x can combine. Everything that's alone, so does not have any variables, those are called constants when they don't have a variable. So a constant is something that does not have a letter attached to it. And then all of the m's can combine. Okay, so this has an x and this has an x. So it's positive 4 and positive 3, which is 7. So we have 7x. 5 minus 10, that's negative 5. And 2 and negative 8 both have m, so 2 plus negative 8, or 2 minus 8, however you want to think of it, would be negative 6. And nothing else has like terms, so then that would be your final one. So now let's just go a little bit more difficult. So if I have 3x cubed minus 5x squared plus 7 minus 9x cubed plus 7x squared minus 5x plus 3. Okay, so now you can only combine, so just like we said before, you can combine things if it has the same letter attached to it. But not only does the letter have to be the same, the exponent in the variable has to be the same. So for example, I have a 3x to the third. So then that can only be combined with another x to the third. So x to the third, I have 3x to the third and negative 9x to the third. So I can combine those together. So 3 and negative 9 makes negative 6. Okay, and then I'm going to do squiggly lines. And you do it in highest power. So 3 has the biggest exponent. So then we're going to go to the next biggest. So then we'll do x to the second. Sorry, I have the hiccups. So then we're going to do negative 5x squared. And I usually will make my students go through and all of the x cubes put a dotted line and all of the x squared squiggly line, just so that they can visually see what needs to combine. So now let's put a squiggly line on the other x squared. So negative 5 plus 7, that's going to give us positive 2. Okay, and then let's just do a solid line. So after x to the second would be x to the first, but we don't write x to the first, we just write x. So anything with just an x, so negative 5, there's nothing else with an x, so it's just going to be negative 5x. Okay, and then the constant, we have positive 7 and positive 3, so that makes positive 10. And when we run out of squiggly, I make them circle or square or heart around them, just so that you can visually see. So we'll do a heart around those ones. And that's all that can combine. So that's adding and subtracting put together into polynomials. Now what if I have something like this? Okay, so for this one, we have a polynomial minus another polynomial. So when we are subtracting one of them, and you can see that there's parentheses, and sometimes parentheses can get confusing, but you'll always see a parentheses when there's a negative in front of it. And the other one is going to have parentheses just for like uniform. So you're going to want to subtract all of that. So the reason why there's parentheses is because you're going to distribute that negative to everything. The parentheses basically says, hey, don't forget that that negative belongs to all three of those, not just one of them. So we're going to rewrite that second one. So I'm going to rewrite the first, and I'm just going to take off the parentheses. I'm not going to write those. And now I'm going to distribute the negative, which means multiply everything by negative 1. So I get negative 5x squared minus 2x, and then minus 7. Now if one of those were negative, say that was negative 7, it'd be negative times a negative, so then it would have been positive. But it's positive here, so negative times positive is negative. Okay, and then we combine all like terms. So I have 2x squared negative 5x squared makes negative 3x squared. A 4x and a negative 2x gives us positive 2x. And then negative 8 and negative 7 gives us negative 13. So that would be adding and subtracting. So now let's go through multiplying and dividing with exponents. So, oh, and one other thing. Your book goes like this. And I don't know if they have parentheses or not. I think they did. So they write it like this instead, which is the same thing. Just distribute that negative. So on the top, it's just 5x plus 4. And let's distribute the negative, so then it's negative 3x. Negative times a negative would be positive 4. And then we combine those. So 5x and plus negative 3x would give us 2x. 4 plus 4 would give us 8. And you just line them up like that. If it were addition, then I can just do it right away. So 5 plus 3 is 8. 4 minus 2 is positive 2. And that's it. Okay. So multiplying and dividing with exponents. So if we multiply, then let's say that I have x squared times x to the 4th, okay? So when you multiply, if I have x squared times x to the 4th, really that's saying, I'll do it down here. So x squared is x times x, and times x to the 4th would be x times x times x times x. 2, 3, 4. And if you can see, that means that if I have x squared times x to the 4th, that's going to make 1, 2, 3, 4, 5, 6. So x to the 6. So what you do when it's multiplying, all you do is you add the exponents. So as long as the variable is the same, then we're just going to add those. So 2 plus 4 is 6. So x to the 6. Okay, let's try another one. So I can only multiply them if the variables are the same. So a to the 7th times a to the 4th. So we're just going to do the a's. So we add the exponents. So 7 plus 4 is 11. So a to the 11th. And then 6 plus 3 is 9. So b to the 9th. And that's it. That's all you do for multiplying. Okay, let's do dividing. Okay, so if I have x to the 5th over x to the 3rd. Okay, so for x to the 5th times x to the 3rd, once again I'm just going to write out x to the 5th as x times x times x times x times x. 1, 2, 3, 4, 5. Okay, and then x to the third, that's just going to have 3 x's. So 1, 2, 3. And when we're dividing, we can cancel out 1 for 1. So these x's are going to cancel each other out. These x's will cancel each other out. And these x's will cancel each other out. Which leaves us with 2 x's. So x times x is just x to the second, or x squared. So if you look at that, all they're doing is they're subtracting. So they're doing 5 minus 3. So 5 minus 3 is 2. So it's x squared. So the only tricky part, though, is that you have to put your answer. For example, let's do another one. So if I have x to the 7th over x to the 14th. Okay, so right here, on our first one, the top had the biggest exponent. And in the bottom, it was smaller. This time, it's reversed the other way around. I put the bottom has the bigger exponent. So you always put your answer where the bigger one was. For example, right here, this is over an invisible 1 because we can make anything over an invisible 1. So we put 5 minus 3 was 2, and we put it on the top because that's where the bigger exponent was. In this case, the exponent is bigger on bottom, so then our answer to this is going to go on bottom. So 14 minus 7 is 7. And that's going to go on bottom because 14 is bigger. And then you can never leave a fraction empty on top. So we write a 1. Okay, let's try another one. Let's do it with more than 1 now. Okay, let's do A, B, and C. So A to the 5th, B to the 10th, C to the 3rd, all over A to the 2nd, B to the 25th, and C to the 8th. Okay, and assume that there was no, let's start with A. Say that there was no A. If there's not another A, then you would just write A to the 5th over there. Okay, so right here we do have A to the 5th over A to the 2nd. So we have to look at just the A's, and we're going to see which one has a bigger exponent. So this one has a bigger exponent, so we're going to do 5 minus 2. And 5 minus 2 is 3. So we're going to have A to the 3rd, and we have to decide, are we going to put A to the 3rd on top or on bottom? So we're going to put it on top, A to the 3rd. And we're going to put it on top because 5 is bigger than 2. So we put it where the bigger exponent was. Okay, for the B's we have 10 and 25. So it's bigger on bottom. So our answer for the B's is going to go on bottom. So 25 minus 10 is 15. So we're going to have B to the 15th on bottom because 25 is bigger. Okay, let's do C's. So we have 3 and 8. 8 is bigger. So 8 minus 3 is 5. So we're going to have C to the 5 on bottom.